After going through the pandas library, now it's time for a new library called Matplotlib. You may know it. It's already implemented in Python, so we're going to use it as import package. Uh, in other words, Matplotlib is a library just for visualization, mainly for 2D plotting. Like graphs that have scatter plots, pie charts, bar plots, etc. Um, we are gonna go through the same data set that we have with the x, y, and z axes. Three characteristics of the sensors that we have: four different sensors for chest, belt, ankle left, ankle right, given with anomaly if a given anomaly is detected. Now let's start. First of all, we need to implement the package. So we are importing matplotlib, mainly SMPL. For telling, and especially we need to import from the matplotlib pyplot. This pyplot SPLT is implemented for having, let's say, a figure, as you can see, a given pyplot. If you have point here, show. Now it's empty. It's like a given graph. Just let's make one figure. So plot figure. And here is one plot, as you can see here, figure size given with 0 axes. So it's an empty figure like a given graph. Now let's make some simple functions. Also important part is to say that the matplotlib is called inline. This comment here means that we are having matplotlib on Jupyter Notebook. If you are running on some other, let's say, local host, like AP, like PyCharm or Visual Studio Code, then you don't need to add this line right here. Now let's say let's create one figure and let's plot uh, the x values from the data set, and let's make some sign. So we're gonna import numpy. Numpy, it's a package in Python. It's in. You will learn about it if mainly if you know Python, you know about NumPy. It's package that it's used mainly for some mathematics like arrays, reshaping of arrays, making some sine, cosine values. It's mainly the basic mathematic functionalities together with all functions of arrays, and it's like a base component, a core component. The NumPy array is a core component of the data frame that is right here. This is a data frame of all tables that are called with pandas. Now here I'm gonna call NumPy with sine x, and what we are missing. So here we don't have x, we have dfx, or you can call with this expression right here. And now we can tell how the line should be. So we're having one line right here, and the next we can make it with a cosine, calling cosine of epsilon, and with maybe two lines. Now you can see these are like more accurate, more close dots. These are like, let's say, with bigger distance, but you couldn't see the difference because you can't see the difference because the points are very close one to another. This is just one type of a basic function and visualization in Matplotlib. We're gonna make just this in two different plots. So in subplots, as I said, the plot figure, it's one figure, and we can make a subplot to it. So we are subplotting so this means that we're having 2 on 1. So the graph is 1 and 1 more on 1. So we're having like 2 rows and 1 column representing. And here is the first row calling. Now in the first row, we are having plot of, let's say, this function right here, and calling the second subplot. Now we are having again the same 2 rows and 1 column matrix, and on the second row we are having the second plot. At the end we can go plot show. Now we have both functions in different subplots. Now let's start with the visualization of the data. This was, like I said, just examples. Now, first histograms. With calling hist from the plot, we have, as you can see, x, the values. Now here the bins, the range that we have, the density, the weight, the type of bars, that's default. We have bars appearing. Now, let's take the data from X column. Now, face color, it means the color of the bars. We can say Peru. It's like orange. And the edge color, the edges of the bars will be blue. At the end, how many bars we will have? 10, and we will make plot show. Here there are, so we have 10 bars in the density. So we have for value of 10, maximum is the value of 8. For x, it has approximately 1,400. What the histogram says to you. So this is the important part, let's say. It makes some summarization of the values depending on the number of bins, and collects the data starting from here 7 till, for example, here is 8.3. These values are taken, and all the x instances that are with these values are summed up or counted, and the rows that have approximately 8 value for x are 1,400. With this, we can see the dependency that the data, not dependency, the distribution that the data has. So sometimes you have to make the bins more summed up, but here, as we can see, we don't have some clear distribution. If we go to 15 bins, we'll have something like this. The next one is if you want to know from the histogram, if you want to know the values of n bins and the patches. Now, if we take a look of the values, we will see that for n, we have the numbers. So how many x's are appearing for 6, for 7, for 8, etc. Um, Here in the array, we have the median of the first bar, so it's 5.9 for the second bar, 6.8 for the third bar, 7.6. So the main frequent values for the given bar. And at the end, some patch object, it means it's object that creates the bar depending on the x and y values on the graph. So they are object and are not so important as the previous values for us. Now, if you want to create, let's say, two histograms, we can make plot histogram, now calling for y value, face color arrow, and the edge color, let's say the same one, blue, the beans 10. Now the second histogram will be, for example, the Z values with face color red, edge again blue, and beans 15. At the end, plot show. Now we have just 1 second here. We have edge color, not just edge color. Now you can see here we have both histograms, the one for x and for y and for z in one graph. The next part, as you can see now, what's here from the histograms, I can say that for z we have some like mainly normal distribution, like a bell. For z, it can be exponential because it has a peak at the beginning on the function and then is decreasing monotonic if we don't take this part right here, but sometimes here it has maybe an outlier or some noise. But for the x data, I couldn't tell the distribution. That's made when you may in the course for data analytics, when you need to determine the function, you need to make the likelihood function for seeing which it's the distribution that the data has. Now, as I said, we are going to the pie charts. Again, from plot, we are calling pi as a function, and now I can have the, let's say, the sensor data again. Now, what we need to know, I will go to one now. As a first value are the frequency of the sensor, so I will go with value counts, and with the value counts I get the frequency for each of the appearing sensors. And now I need to take the values. This is the index, the name, and here is the value. So I'm taking the values and then making a list from them. Here I have the frequency for each of the sensors as x values. Now for y values, I need the labels. So for the labels, I need the names. So labels will go with the names. If we take a look, here is the plot chart. Now, as you can see, we have a given text. On a given x and y values, it says label anchor left. given text. It means x and y values given text. If you want this part to be hidden, you need to make plot show. And then what's given as output of the plot_py function, it's not printed out. If you want to customize your chart, then we can add colors. For example, 4 colors like dark orange, then sandy brown. We have in this spectre dark salmon and orange red. All of these are like in the same scale, in same spectre of orange, little bit, some of them rose. Plot_py. Now again the same plot_py. Here we are adding now colors, a list from the colors, and we're gonna add a text here to be filled with the percentage of the data that we have. So autofill, auto ECT, we have format of decimal appearing at the end, plot point show. Here there are. Now we have these are percentages. Let's say. So what's important? Here we have the percentages and the labels of the given sensors. As we can see, the anchor left is having most of the data appearing with anchor left as a sensor. Now, one more parameter is, for example, explode. It's a set of where to be placed this part from the pi. So 0, 0.1, 0, and 0.3, for example. And here I will add explode. And, explode. Here it is. So as you can see, if I print out the labels, first anchor left, it's on 0 point. Then belt is just a little bit on the left, it's 0.1 exploding. Then 0, the chest, and ankle right is at most. If I can write here 0.5, you can see the chest goes really with a big distance, so maybe 0.2, and they will be all like explode. Maybe the visualization, I think, is the best like this. So that's how we make customized pie charts. With the pie chart, they are best used, for example, when you have some textual data, let's say some categorical data like this with belt, ankle left, ankle right, chest, some sensors, or maybe some products, and you want to see the sale of a given product, or you have some house components of the smart home and how they are usable or how frequently, and then you want to show the percentage of usability. The next one is the box plot, calling with again PLT box plot. Now for the box plot, we can have a look for a given value. As you can see, we're having for x starting from, for example, 6. Here is the minimum and 18.5 maximum value. Uh, Here the orange line is the median, the third quartile, and here we have first till the second quartile. So here is the second quartile at the half of the median. So the data is most frequent in from the first till the third quartile. With the box plots, we can take a look if there are some outliers. So now we can make a box plot of all, let's say, we're gonna take a box plot for X, Y, and Z sensors. So calling it for ilog. Let's take a look. Like I said, ilog function, it's the first argument for columns, the second, the first for rows, the second for columns. So if we take a look, this is the whole data set. I can say just two columns two rows, for example, here they are, or just first two columns. Now I will take um, the first three columns, or it can be -2. It means the last two columns till the last two columns. So it's the same. I will add it right here. And now let's take a look. So no, here PLT. Now it's just gonna run like this because we have some error appearing. I'm gonna just interrupt it. We need to make this numpy array so it's not a data frame, because as a data frame, here, as you can see, it's not recognizing it well. It's making box plot of each instance. So we need a numpy array. What the numpy array does, let's take a look. It's having for each of the rows one array and implemented in a matrix, is two-dimensional matrix. So numpy array we have, and here I missed just to end the brackets. Okay, here there are. So as you can see, for X, for Y, and for Z, the values. We have the median, minimum, maximum. We don't have outliers. We have from the first till third quartile, and here we can see how the distribution goes. As you can see, the median here is almost at the half, so because of that we can say the distribution is normal. Here it's mainly it's going the median in the first quartile. It's really close, and we can tell that is some exponential distribution. And right here at X we couldn't tell anything because the median is mainly on the upper bound, in closer to the third quartile, but not so it's not so close. Even it's in the middle, it's in the halfway to the median, to the let's say to the half of the box plot, and to the upper case of the box plot. So this distribution of X can be determined. One more type of showing the box plot is violin. So we have violin plot. And here again, we have the same calling, the same X, Y, and Z sensors. Now, as you can see here, we don't have the medians. I'm gonna add here to show medians to be on true. The default one is false. So here we have like violent shapes, as you can see. um, why this is like, what's the cloud right here appearing is the fraud. It means how the data is collected, how many of the instances are appearing in which quartile. As you can see, the median is right here, here, and here is the same as the box plot, just let's say a different figure. If you want to customize the violent plot, we can add, for example, colors. So it can be blue, gray, uh, and lawn green. Now we can go for the X sticks. So what's X sticks is here 1, 2, and 3. These x6 are the numbers appearing on x-axis, and we're gonna say that in values of 1, 2, and 3 we want to have on 1 x appearing, on 2 y, and on 3 z. Now for let's say this is a vp variable. Now for E in range from 0 to length of VP bodies. These bodies are the bars, the box plots appearing. We're gonna take each of them from E and set the face color to it. So face color, colors of E. Now if we take a look, here are X, Y, and Z with different colors appearing. The next one is a new type of plot, a steam plot. A steam plot is a plot that, let's say, is better to use when you have a negative and positive values. It can clearly show the dependence between them, and if you have more than one steam plot, then it will show you the values for more, let's say, um, more features, the dependency between them, etc. Let's take a look. So stem. Now here df for x, and let's say for y, we have marker. Let's say, let's be with the default one at first. Now we need to wait a little bit because it's making for each, as you can see, it's making for each instance like a line and a point for each of the instances, so 5,000 approximately. Now, if we say some marker to be appeared, a blue one with a line, uh, a blue one, and let's say the line to be red. Here there are, so now you can see how the instances goes, and maybe add base to be green with points. So now if we take a look, we have values for x and y appearing. Here are the real values. This is just the line to the value. Here we have the base green, as you can see, the peak is appearing right here for x and y. So mainly the values are at maximum here, at minimum here, at the most. The peaks are right here. You can see the distribution and the dependency of the features. The next one, for taking a look of the dependency, it's the scatter plot. If we want to take a scatter plot of x and y, let's take a look. Um, we have points for x and y values. Again, as you can see, the most of the data is here appearing at the maximum value of x, at the minimum. What is also obvious is that this data, it's not having some linear regression or linear dependency between the features, but how y is growing, how x is growing, y goes smaller. That's the main feature here appearing. It's a float, a cloud of points, but are getting smaller values how x is getting bigger. Now, if you want to add some customization to this plot right here, we can add x label or name of x-axis and of y label on y-axis, adding y. We can add a title, let's say sensor signals. At the end, let's say plot show. Now we have x, y, and sensor signals, maybe more clearly for the clients, or or if you are adding this to a presentation. Now, for because we have x, y, and z, we are gonna implement a 3D plot. What we need is an instance for the figure. And calling figure to add a subplot. The subplot will be 1, 1, 1. It means 3 dimension with a projection of 3D. Now I'm calling to the projection a scatter plot that will be of x values of the sensors, y, and at the z-axis z values. Here we are having plot show. Just a second. Subplot missing a letter. Here there are. As you can see, they are now in 3D system, a 3D graph. Again, we can add x, y, and z labels. But why is this? Need to make. We have access of 3D subplot. Now, if we take a look. And now we need to make it's different. It's not x label, is set. I think x label, and we have here appearing, for example, x. Let's take a look. Now here is x. We have for y and for z the same. Y, z. So here is z, y, x. With that, we created um, 3D graph that appears all the values at for x, y, and z of the given sensor. In the next video, you will take a look of one more library that will help you make even better visualization.